Okay, it is great to be here with you all today. And those running the board, I do tend to speak loudly, so I hope I don't blow out your speakers or anything. So when Petra told me about this conference and that this was going to be the first FINHTML5 conference, I really wanted to be a part of it. I wanted to be here to experience it. And so far, it is exceeding my expectations. It's so amazing to see you all gathered here today and focusing on this one item that's going to affect us all and affect our companies and affect our businesses and affect the way that we live our lives. So I do have one complaint. The complaint is they put me on after two people with British accents. So I always think people with British accents sound very intelligent. And so, you know, it makes me feel like I need a British accent in order to compete with them. And I just don't think I can pull that off. So you might just have to pretend in your mind a little bit that, you know, you hear that British coming out. But it's going to be good old USA. Sorry about that. Now, also, to try to keep you engaged a little bit since we're quickly approaching the lunchtime, I do have a few giveaways here. So for key questions that are answered, I'll throw some t-shirts out to you in the audience. So answer the questions. Now first, we're going to be talking about the rebirth of touch. So let me start by talking about my experiences. So I'm a hacker. And to me, being a hacker means making things work. So we take what we have and we build something new with it. We make things work that might not be out there today. And that, to me, is the hacker mentality. I am the HTML5 evangelist at Microsoft, and I'm located in Redmond, which is the headquarters for Microsoft. And it's a really great experience. I'm actually new with the company. I've only been with Microsoft for about 7 months. And before that, I was a developer. And I still consider myself a developer. And I've spent over 10 years working with different companies, producing awesome web apps. I'm a JavaScript developer. It's been my first love and still is. So I'm the HTML5 evangelist. I blog at html5hacks.com, which again, where we just focus on making things work with HTML5. You know, we look at what's out there, where gaps are, and we try to solve them. We try to bring in some fresh perspective on how to implement the technologies that are out there today. And of course, we put it into a book, and we have HTML5 Hacks that's out by O'Reilly. And I'll talk a little bit more about that at the end. But you kind of see a trend here. HTML5, HTML5, HTML5. So for me, I see the future being in HTML5. Now, one of the things that isn't actually part of HTML5 is what I'm going to be talking about today, which is touch. So there's an assumption that touch is part of HTML5. Now, when we talk about HTML5, we're really kind of referring to a family of technologies. And I would totally agree, yeah, touch is part of that. But it's not really part of the core specification. And until recently, there hasn't been a specification that we as browser makers can all get behind and implement. So I'm going to start out with a little test. Can anyone tell me what this is? Oh, there you go. Where did that come from? Oh, boy, you're going to make it hard, aren't you? Oh. I'm a computer guy, not a, no excuse. All right, well, you can thank the guy up there for getting you that T-shirt. And I imagine that's how all the T-shirts are going to go, so you can just be prepared to be disappointed. It's a laptop. It's a computer. So we know how to write for computers. We know the inputs are going to be a mouse, a keyboard, a trackpad, whatever it is. We know how to write for that. We know how to write for click. We know how to write for mouse up and mouse down. It's something that we have been doing for years. We know what this is. This is a smartphone, right? It has a touch screen, has touch input. You can zoom in. you can swipe, you can tap on it. And as developers, we know how to write for touch. You know, we haven't been doing it as long as we've been doing it for click, but we know how to write for touch. We also know how to write for an app that handles both, right? That can do touch or click. But then we had these come on the market, and these are a variety of Windows 8 devices. And the reason why I highlight Windows 8 isn't just because I work for Microsoft, but because it's a new paradigm for us as developers. We now have devices that have both touch and click. And a user can go back and forth from touch and click while they're using your application. They can load up your web page and start using the keyboard and then pick it up and start using the touch screen. So we have this new paradigm of satisfying our users' needs to write an application that can handle both touch and click. So when we think about HTML5, you know, we think about generally devices like these or devices like these. We think about how they're going to work on touch screens. Well, HTML5 is not built for touch. It's not specifically for small devices. I had one of our amazingly attractive Microsoft models do a little demo for us. So I'm going to play you this little video here. So you all know HTML5 games are great on a device like this. Little screen, touch points, makes for a fun little game. But you know, HTML5 games also work really well on a little screen like this. Cut the Rope looks so real on this, I think I could actually eat the candy myself. Let's give it a try. Well, maybe next time. Enjoy the game. You can't do a video like that with a British accent. Sorry guys, you know, it only works for me. So HTML5, so we have this game, right? We got Cut the Rope. It runs on the phone, it runs on a tablet, it runs on a desktop, and it runs on like a huge screen like that. So here we have a technology that can wipe across all of these different screens, these different sizes, and meets the needs of the users no matter what device they're using to approach. So let's talk about touch. So touch can be implemented poorly. And if you implement it poorly, it's going to cost you. It'll be painful to implement, and it's going to cost you in the end. So today, we write touch like this. We do a feature detection, which, by the way, I'm all about feature detection. I think that's definitely the way to go. But we look and we say, okay, does your device support touch? If it does, we attach listeners for touch screens. And if it doesn't, then we attach listeners for click. So that's a good idea, right? Well, the problem is when we go back to something like this device, where I can be touching the screen and then I flip out this keyboard and I'm using a mouse, if I've loaded your app using this feature detection and you've detected that I have touch, well, now my mouse isn't going to work in your application, and vice versa. So I do a little review here. Let's start with what we know. Okay, we know mouse events. We understand this model. It's a very clear model. We have clicks, double clicks, mouse down, mouse up, mouse over. This is a language that we're used to speaking with events. We understand that we can write our applications, we can attach these, we get an event object that then has information in there that we can use to control our application. So this is a event that we've been working with for a long time in JavaScript. So Apple had come along a few years ago when they released actually it wasn't even with the first iPhone release, it was with the second release that they added touch start, touch end, touch move, and touch cancel as well. So they had this great multi-touch support event model that allows you to write for multiple points touching the screen at the same time. Whenever you use this, you get a array, or really a collection of touch events inside of your event model. So inside of that event model, you have a collection called touches. There's actually a couple of them. We'll look at them in a sec. And then inside of touches, we'll have a collection of each of the different touch points on the screen. Okay? Now, when you're writing your application, if you write for click instead of touch, it will work with an iPhone, right? Because the iPhone is going to fall back to the click, and generally it'll be like, a 300 to 500 millisecond delay between the time a user touches a screen and the event fires. But it will fall back to touch, but if you write for touch, it doesn't fall back to click, right? So if we write for touch events on our screen, we can't assume that someone's going to be able to use a mouse and keyboard on their application. Okay, so inside of that event model, we have 3 collections. The first one is touches, which list every finger currently touching the screen. Okay. Target touches, which is every finger that's currently touching the target that the event is attached to. Then change touches is all the touches that have changed in that event. So these are collections instead of arrays because they're live. They change as the user changes. So if the user starts with 3 fingers on the screen and then goes down to 2, these collections are going to change likewise. So I have a little video here that's going to simulate what happens when I'm touching the screen, and you can see I'm lifting 1 finger at a time. And let me tell you a little bit about what the code is here in the background. So every color represents the position in the collection. So one of them is 0, one is position 1, one is 2. And so every time you lift a finger, it changes positions. Now I lifted finger 1, and then I lifted finger 2, but I never lifted finger 3. Okay, but that third finger changed positions twice because of other movements on the screen, okay, because other fingers changed. So the reason why I point this out is because a lot of times when we do develop for touch, we use the array positions or the collection positions as our touch identifier. Well, we say if you are position 1, then we know that you're the first finger. If you're position 2, we know that you're the second finger. But you can't trust that. You can't rely on what position you are in that collection to know which touch point you are. And this is kind of the sample that we had there. What we're doing is we're looking at the touch move, and then we look inside of that event object for event.touches.length. And then we loop through there, and I'm changing the color for every different position in the collection. So we talked with a lot of developers and collected some feedback as to, okay, well, what do you really need? What is it that you don't like about the way things are implemented today? And remember, what Apple produced was not a W3C standard. It was an implementation that they put in their browser to meet a need that they had specifically. Other browser makers have come along and adopted versions of what Apple had put in, but there was no standard for all of the browser makers to agree on. So this is what we came up with. Okay, so touch views are always, touch events are always viewed at an aggregate level. So you can't at any point look and get an event for each of the fingers. Okay, you have to look at your event model as a whole and then look inside that collection and dig into each of those events. So you require different code to architecture for iOS mobile than desktop browsers. So it's great that we have a lot of libraries that go in there and solve that for us, or do as best of a job as they can at solving that for us. But as web developers, we want to be able to write our code once and have it work everywhere. We don't want to have to write special code for every platform. The delayed fallback to a click. So it would be really great if we didn't need multi-touch, that we could just use click on our applications. And yes, it does work, but the delay is generally enough to cause a poor user experience. And none of us want poor user experience in our apps. There's differences in touch models. So Apple implemented their touch model, and then other browser makers have come along and implemented similar but different touch models, and that's almost worse than implementing completely different touch models because it makes it harder to detect which model you're trying to write for. There's no equivalent to a traditional click. So we have touch down, we have touch up, but we don't have a tap. And it's not a likely candidate for standardization. So a while back, we did try to put a group together to make a touch standard. And this was, I think, a poor interpretation of what really happened. So Apple had intellectual property rights on that touch event model that they had written. So it wasn't that it wasn't a good standard for the time, but they owned that. And just as I would want anyone to respect the intellectual property rights that Microsoft has, we want people to honor those rights that Apple has as well. So it didn't make sense to build a standard around what was already implemented. So now we have pointers. So we're going to talk a little bit about pointers. Pointers is a new standard that the W3C is working on. And we have the majority of the browser makers and a few other companies engaged in this group to help define these standards. And what is different about pointers is pointers resolve down to a single event model. So it doesn't matter what input type you're using, whether you're using a touchscreen or a mouse or a stylus, they're all going to resolve down to pointers. So as a developer, we write for pointers, and then it works on a touch screen, it works with a mouse, it works with a stylus. So pointer model is pointer down, pointer move, pointer up, over, out, and cancel. That's what's in the spec right now. There is both a pointer event submission and a working group in place for this specification. And one of the really great things about the way that pointers are written is that they're just like the traditional click event. So we know how to write for click events. We've been doing that for years. So writing for pointers are the same. We can take the same code that we have written for a mouse, right, with a single input point, and update that to a pointer, and our code is going to work. The difference is that we're going to get a lot of additional data inside of that event model that we didn't have with the traditional click. And we'll demo some of that in a minute here. So this is basically the little illustration that goes along with the standard there. Instead of writing for touch and pen and mouse, we instead write for the pointer that will represent all of those inputs. And one of the great things about pointers is that this is what we're supporting today, right? But the next time a new input type comes along, and trust me, more input types are going to come along, okay? Touch is not the end all. It's not the natural input. But when they come along, they also can resolve down to pointers. So whether it be something like speech or connect or movement or whatever might come next that we want to standardize on, we could also resolve that down to pointers, and we as developers wouldn't have to rewrite our code. So this is a little bit of a Microsoft brag. We're so excited about the work that's going on with pointers. And right now, IE10 is the only browser that has implemented an experimental version of this specification. But we're so excited about it, we actually wrote code for WebKit and submitted it to the project. So we wrote the code for the pointers implementation of WebKit and submitted that. If you want to try that out, there is a website, html5labs.com. You can go there. There's a link on it from the front page right now, and download that to your WebKit build. But we're really excited about what's the feedback that we're getting from it with IE10. And we're really excited about the feedback that we're getting from the other browser makers too, about how they see it being done in the future. Okay, so I'm really not that good with slides. It's pretty impressive to me that I've stuck to my slides this long. But I'm going to go into do some demos now, because I really want to show you how this works. I can talk about it all day, but I want you to see it. I want you to experience it for yourself. So we're going to look at a bunch of demos here. So I am working here on a Acer Ultrabook that has a 10-point touch screen on it. Let's start here. So I have some little kids at home. Is there anyone else here with little ones? Thank you all for staying awake this long. That is impressive. Now, I have a 2-year-old, and when you have a 2-year-old, as a parent, you look for ways to invent things to keep a 2-year-old occupied. So this is what I came up with. This is about 1 million HTML5 logos, and as you touch the screen, you know, they follow your fingers around. It works with a single touch point, right? Works with multiple touch points, works with 10 touch points, however many your screen is going to support. I can then go and change the mode of it a little bit. And I can tell you, something like this can keep a 2-year-old busy for like 20 minutes. And that's like 6 years in 2-year-old time. It's awesome. Yeah, I will. All you parents out there are going to need it, right? Okay, so something like this, it's the way that we implement it, and I'm going to show you the code, and if you're not a developer, just hang with us because I'm going to try to just look at it from a high level to help you understand what's going on. But what we're doing here is we're tracking the fingers, okay? We're looking at the fingers out of the screen. We're looking where they were and where they are to apply some physics to try to figure out how that would affect the area around them, okay? So in order to do that, we first have to detect what type of touch input you're using. Okay, are you using a mouse? Are you using touch like iOS, or can we use pointers for this? Okay, so if you're using a iOS touch model, then what we have to do is we have to get inside of that array, and we have to look at each of those pointers. Okay, so we do our test here. And then for each of those fingers on the screen, we have to loop through that to look where each of those fingers are and where they've been. Now, we're actually making an array with the touch points. So you would think that we would be able to translate the collection from the iOS touch event model and just move it over to an array, right? But the problem is we have to know which fingers we're following. We can't just trust the collection based on the position. We have to register each of those points with the array so that we know that finger 1 is moving where we think finger 1 is. Remember the video I showed you a few minutes ago where those positions changed? Well, because they can change, we can't actually trust that collection. So we have to, instead, every time we're redrawing the screen, we have to do a loop through that collection to pull out each of those touch event objects. Now, whenever we're working with pointers, it's actually quite a bit easier. Now, this is the same code that I'm using. I'm checking if you are a pointer or if you're a click model, I'm using the same code. Okay, because the way that works, if you're click, you're just a single input, right? It's just like having one finger on the screen. If you're using a pointer, it doesn't matter how many fingers you have on the screen because they're each going to produce their own event model. So if you're using a mouse, it fires the function one time. If you're using your fingers, it's going to fire the function for however many times you have fingers on the screen. So if you're using 3 fingers on the screen, 3 different events will be produced, and 3 different listeners are going to be fired. All right, so basically it's the same code that we wrote for click. We're using that for listeners as well. Now, the listeners have IDs that are associated with them when you're using pointers. That's some additional data that you get. So we actually have an ID for each of those pointers. So instead of having to loop through our events, we can track them by the pointers. Or excuse me, by the pointer IDs. Now, again, whenever we're drawing on the screen, we have to add some additional code to loop through the collection when we're using the iOS model. So because we want to make sure that we're supporting all of these inputs, we actually have to write some special code for the event model for iOS, and then we can use a unified code base for all the other event models, which would be pointers and click. Now, as developers, we want to be able to write it one way. So that's why this specification is going to really impact the way we write our applications. Because we're now going to be able to write a single event code base that works with both click and pointers and any touch events that resolve down to pointers. Okay. So next, let's change this. We're going to take this application, and this is a brick breaker application, and I'm going to transform it from a click-based application to being a pointers-based application. Okay, so let me demo this for this first. You have a paddle on both sides, and as I move my mouse from one side to the other, I can then control the paddle on that side of the screen. So I'm going to choose my blocks here. And I'm really not good at this game, so go back and forth. Now, it's written for mouse, so I can use my finger and it'll work. But what I can't do is I don't have the systems aren't written to have two mice at the same time, right? So I can't use two touch points at the same time. So let's look at this code a little bit. Now, what I have here are four events, they're written for mouse up and then mouse move, okay? So I've got two sides of the screen, and I want to register when the mouse comes up, which releases the ball, and when the mouse moves, which moves the paddles. So I have two events for this side of the screen, two events for this side of the screen. So I'm going to change these to be MS pointer up and MS pointer move. Now, the reason why they're prefixed with MS is this is an early implementation of a spec. So anytime that we have an early implementation of a spec before the spec is finalized, we consider it experimental. As browser makers, we consider it an experimental implementation, which means that as the spec changes, the way it works in your browser can change as well. So use at your own risk. And a lot of times we make assumptions that it's okay to use our dash WebKits and our dash MSs and not worry about it. Warning, when it has a prefix, it's experimental. It will and can change on you. And I'm sure Financial Times, with database implementations, can tell you that there's risk with using some of those early ones because you've got to keep up with it. You've got to track it and make sure that you change your app as the specification changes. So this is the experimental implementation, so the MS pointers. So all I did is changed these four events, right? I just changed them right here. I didn't have to rewrite any code. And now I'm going to refresh my page. So it still works with the mouse, right? But now it's also going to work with touch. Oops. Told you I wasn't very good. And as you can see, I can use now 2 fingers at once. So this application that was written for a single input point, a mouse, I can now use that same code base, and it works with multiple touch points. Now, one of the other interesting things is because it's a pointer, it doesn't matter what type of input I'm using. So now I'm really doing a left brain, right brain test here because I'm using a mouse on the right side of the screen and my finger on the left side of the screen. So that's the type of implementation you get with pointers. It doesn't matter what input type the user is using, you're going to write your code for pointers and it's just going to work. Yes. Okay. All right. Now, I'm going to go quickly through a couple more demos here. Now, we have the specification for pointers, okay? And the way that a pointer works, you can see here when I touch the screen, I get some additional feedback on the right here as far as like the width and the height of the touch point. Okay, that's something because with a finger, the touch point size can change. We feed that information in through the event model. There's no pressure. Pressure comes when you use a pen. We can read the pressure. Now, we also have gestures. So gestures is a high-level interpretation of what's going on. Okay? So instead of having 3 fingers touch the screen and have 3 different events fired, with a gesture, the OS is interpreting what's going on and just firing 1 event. Okay? So this is something that's implemented in IE10 to make it easier for you so that you don't have to figure out yourself when a user is pinching or zooming or rotating or flicking. So gestures helps give you that information so that you don't have to derive it from the pointer events itself. So we're also looking at ways to implement touch in CSS. All right? So here is the CSS zoom. Now when we use a touch screen, we all know that we can pinch and zoom in on the screen, but there's times when we don't actually want the whole screen to zoom. So what we did is we have the ability to zoom just a particular section of the page. Okay, so here I have the zoom set to this picture of Mount St. Helens, which is outside of Seattle, Washington. And I can just zoom in on that one area instead of being able to zoom in on the entire page. Likewise, we have a carousel built here. Okay, now this is just your traditional overflow of some pictures I have here. And you can see I'm just scrolling. It's not actually snapping to the pictures. And sometimes we want that in our application. So I'm using here a jQuery plugin for a carousel. Okay? And you can see as I flick across, it moves those pictures. Now here is a snap point CSS implementation. This requires no JavaScript, it's just a few lines of CSS. I'll show you that in a minute. And you can see it's actually tracking with my finger. So as I move my finger, it's switching, which is quite a bit nicer than what we see with the jQuery implementation. And with the jQuery one, if I change my mind and go back, it's still going to register that as a swipe. With this one, it's tracking with my fingers. Okay, so now I want to kind of show you a demo, and this is what we're going to end with here. So Martin brought up this morning about when we implemented the web, we had, Web 1.0 was really about consuming, right? It was new. All we used the web for was consumption. And then Web 2.0 came along when we started not only consuming the web, but producing on the web. So we see a lot of the same issue in my mind with touch, where touch a lot of times it's about consuming. It's about playing games. It's about us getting something, reading something, taking something in from our device. So I kind of have a personal mission to move beyond that and start using touch for consumption or for creation as well. So I'm not just consuming things, but I'm creating with it. So I have this little app here, and what my app does is it allows me to create my own cartoon scenario. So I have a cowboy here in a little cowboy town, and what I'm going to do is I'm going to start it out. and it's going to play through the little timeline, okay? Now, I have just a simple overflow set here so that I can go forward and back through the timeline. And I'm going to start it over again and play them. And then I'm just going to start changing the scene and kind of move the background a little bit. Now, what's interesting about this is I'm using multi-touch, but this is touch on two different areas, right? One area is touching a button. The other one is touching the background and moving it. So as I hold the button down on the left-hand side, it determines which layer I'm going to be able to move. All right? Now, when I go back and play it, it's going to play the movement that I had, right? So now I want to add a layer. So I'm going to add a little bit of air moving here. And these are cowboy times, and yes, that is blood flying through the air. So you can see it's playing my last layer as I play a layer on top of that. Okay, so I don't really need to worry about timing. I just watch what I did the last time, and I add the next layer on top of that. So now I'm going to hold down the cowboy button here, and I'm going to move my cowboy, right? March him over to the saloon. And no good cartoon is finished until there's a bird flying through the air, right? So let's move our bird a little bit. I'm going to have the bird follow my cowboy, bring him down a little, and then have him fly back up. All right, now we've all seen real birds, I'm assuming, and there's something wrong with that bird. It's not really moving. So I'm going to use a gesture down here, right? And I'm going to move my bird. There we go. Make him sway a little bit as he moves. And now the one thing that I don't really like is my background is okay, but it's a little jittery. So I'm going to start over again, and I'm going to re-record that. But this time, I actually slid my finger across the button a little bit, which added a Y lock to it, so that it doesn't move up and down, it just moves left to right. So it doesn't matter where my finger is on the screen, it's going to only move the left-right of the background image. So, in essence, what I have here is a multi-touch application written with pointers, with gestures, and it's going to work not only with touch, but it's also going to work with the mouse. So if I take my, let's go back and redo the air a little bit, right? So I'm going to hold down the air, and then as I move my mouse, I'm using my finger and my mouse together. And I can move my air particles. So pointers allow me to build this application, not just the game, but an application that actually lets me create something. And I write it with pointers, and then the user can decide what type of input they want to use. Now, depending on which layer I'm controlling, one input might be better than another. So it might be a little easier for me to use my mouse to move the air, but it's going to be easier for me to move the cowboy with my finger. And it's that type of flexibility that we want with our applications, and that pointers allow us to do. So it's a very flexible model here. I'm running low on time, so I want to jump to the end. Told you I wasn't good with slides. Okay. Didn't really give out a lot of these t-shirts, so we'll just throw them out now. And for everyone else who didn't get one, what we have, sorry people up top, I don't know if I can make it or not. There we go. All right. For everyone else, I have a half off code for you. If you would like to purchase HTML5 hacks on O'Reilly.com, use this auth code, and that'll get you half off. And a little tip, if you wait till they go on sale, sometimes they put the book on sale for half off, and then you use this code, you get it for like, you know, a couple bucks. Also, if you have ever used Browser Stack, it is an awesome, awesome tool for testing with multiple browsers. And I know that not everyone has IE10, not everyone has Windows 8, but you need to test for it. You need to make sure your app's working it. So this is a really great way to be able to test Windows 8 and IE10 with your applications without having to build a virtual machine or get a copy of Windows 8. Now, also, here's a couple Twitter addresses on the bottom. One is your local Microsoft, one of your Microsoft reps, and mine. There's going to be an announcement come out next week about a new tool that will help you test the readiness of your website for modern browsers, not just IE, but for all of them across. And I can't really give you any more details than that, but look out for there because there may or may not be a really great deal with Browser Stack that comes along with that. So thank you all for your time today. I hope you enjoyed it, and I hope that you were inspired to go out and use those pointer events. The W3C group is running, and they're still determining that, so go and participate. Go give your feedback. Tell them how you need pointers to work to make your applications work. So that's what I've got. Thank you very much.
Good stuff.
Thanks.
Awesome. Hey, one thing that I forgot to mention, that actually tomorrow we're going to have another big day with Jeff coming to the SC5 office to run a 3-hour Windows 8 HTML5 workshop. So the event is fully booked now, but if you have a super, super good reason and can kind of get me into giving you a ticket, there might be room for one more. But let's, good. Let's take a couple of questions, and if you guys have any, and we'll get going with Philip's presentation next. So any questions?
See one in the back there.
Hi, I have also a 2-year-old kid, and I also implemented a drawing program, but for some reason it hangs every time he slaps the screen. Do you have any idea? Is it because of too many touches, and what really happens under the hood when you have too many touches?
So that is actually, it's comical the way that you presented it, but it is an issue because different devices have different amounts of touch points. It all depends on the capacity of the screen, the number of touch points that it supports. So there's some Android phones that support single touch point, that don't support multi-touch point. I have a laptop that was built for IE7, or excuse me, was built for Windows 7, and it has 2 touch points. This one has 10. So it's all determined by the capacity of the screen and the driver. Yeah, so if you have more than 10 touch points, like on here, if I lay it down, then it will stop registering touch points completely. Yeah, you can test the number of touch points that you get in a collection and then limit it at that so that you don't have more events that fired. So if you're getting your app that hangs, it's probably trying to fire that function, 10, 20 times at the same time. So if you test the number of touch points that you have on the screen at once and then limit the number of times that your function's being fired, it should help with that performance. Thanks. Sure.
All right.
Hi. I didn't see any equivalent touch in the pointer events for a click or a tap.
There is not. So that's a good point. One of the reasons why we have implemented gestures in IE10 is because there are some really specific types of interactions to Windows 8 that we wanted to make sure developers could code for when their application is running on a Windows 8 platform. So in there, there's tap, and there's things like expand and rotate. but those are not part of the pointer specifications. I don't know of any plans of them going into the pointer specification either. So that's some of those interactions, depending on the platform that your user is on, may be different.
So would you expect them to be in the gestures?
Yes, they are in the gestures, but gestures are not part of the pointer specification.
All right. Let's take one more question, and Jeff, you're going to be anyway available
Yep,
here
I'll be
for
around,
the
yeah.
whole day. So if there is this one.
Yeah. Actually, the question is following. JavaScript is a single thread
Yes.
thing. And now if you have a touch event with multiple touches, it's all processed within a single callback. So you can basically complete your processing knowing all the touches. But in pointer case, you would have several events which will be processed one after each other, and you have to do the processing based only on the information which you have about a single event. How is it addressed in this pointer specification?
So as developers, one of the reasons why we write that way is because of the way that Apple implemented it, right? To have a single event model that has all of the touches inside of it. If we go back to the way that we write applications for mouse, then pointers will work with that model. So you would want to, if you have 3 touch points on the screen, fire each of those functions separately. So you don't, instead of looking at it as an aggregate, you need to look at them as individuals.
So basically, if now you have to analyze what kind of coordinates you have to figure out what is happening on the screen,
Yeah.
now you have to piggyback all the events, and then after each event, you have to analyze what you have already recorded to figure out what's happening on the screen.
So you do have a history because you can follow those touch points. They all have IDs associated with them so that you can track them as they're working through your application. Is that your question?
Well, basically my question is, now we had to do one type of processing within a single event. Now we have to do pretty much the same type of processing, but distributed over many events.
Yes. And again, I'll go back to the fact the reason why we do that single processing of all of the touch points is because we are conforming to the way that the model was. Pointers being a specification, we will be able to write to pointers and have them work across all browsers. So yeah, we would have to change the way that application work, right? We would want to write it differently to work well with pointers, knowing that we'd be able to implement pointers across all the browsers.
Okay, thanks.
All right.
Yeah.
Hey, excellent questions. So as I said, that Jeff is going to be available, and obviously you follow Twitter and other means to connect you. So please keep up the discussion. But thank you once more.
Thanks for having me.
It's going to be another great day with you.
Yeah.
So thank you.
Thank you all.